Okay, so we're going to be graphing Santa Barbara, California's sinusoidal tide graph. Okay, so the key things are 4 o'clock on June 1st. That's where we're going to start. So that's going to be our y-axis here. Right at 0 on the x-axis, I guess, would be 4 o'clock. 4 o'clock p.m. It's going to be at the tide is in or it's high tide. So that's 20. So it's going to be right here. So, you know, one full cycle, it's got to end at high tide also. So we have to remember that. So now, at 11 o'clock the same day, that's 7 hours later, right about here, I'll make it. At 11 o'clock p.m., this is June 1st, we reach low tide, so that's at 4. Okay, so when will it be high tide again is an important thing that we should know. So this is 7 hours, so 6 a.m., 1, there we go, 7 hours later. Oop, nope, 7's here. We're going to at 6 a.m. This is going to be 6 a.m. June 2nd. Right here at 12 o'clock is where it changes to June 2nd. So now we're going to make it at this time. It's back at high tide. And we'll continue this model. You know, you could keep going. It does say you only have to sketch one cycle. So that's what I did. All right, so now derive a sinusoidal model. So what that means is write an equation. So remember, to write the equation, the 3 things that we need our max, we need our min, and we need our period. With those 3 things, we can do anything with these graphs. So the max is 20, the min is 4. So remember, these are all on the y-axis. The period is the x-axis. How long does it take to make one complete cycle? So how long did it take to go from here to here? Well, that's 14 hours. 14 hours. So those, I have it. I'm done. Now what I have to do is I have to find my, pieces. So my D, to write the equation, I need D, I need A, and I need B. So max plus min divided by 2, so that's 24, so that's 12. Max minus min divided by 2, 16, so that's 8. And the B, 2 pi over B equals 14. So when we cross multiply and solve, we get pi over 7. So the equation, and I'm just going to do this, I'm going to write it with f of x, is equal to A. Now it starts at the max up here, so I do know that 8 is positive. A, it's cosine because it starts at the tops, cosine B x plus D. So if we wanted to, we could sketch the midline at 12. So right in the middle of these two would be 12. Predict the depth of the water at 8 p.m. on June 1st. So 8 p.m. on June 1st, if we look at our graph here, this is 4, so it's 5, 6, 7, 8. So this is 8. I don't really know what that's going to be. My graph isn't that accurate. So what I have to do is I have to plug in a number. Now, we don't plug in 8. We plug in how many hours since 4. So this is 4 hours. So here to here is 4 hours. So I'm going to plug in f of 4 to do C. So plug it into this. You should show your work. So it's 8 cosine pi over 7 times 4 plus 12. So when I plug this in, I get 10.2198, etc. Okay, write it all out. I just ran out of room here. I'm trying to move it over. It's just not working. All right. I am losing my mind. So 10.21983253. And is the tide going in or out? Well, here it's going down. I'm on this part of the graph, so it's going down, so the tide is going out. At what time of the day will it be high tide again? Well, I figured that out. This is here. This is high tide, so it's 6 a.m. And it's going to be on June 2nd. Messy, but, you know, all good. Okay, this one here is you're using the equation, and you just have to get the information out. So what is the highest you will reach? Well, that's your max. So the max is positive 60 plus 66. So that's 126. Oh my God, I hate this. Okay, what's the lowest you will reach? Well, it's negative 60 plus 66. That's the min. Or just, that's all it is. So that is positive 6. Okay, how long will it take you to go around the Ferris wheel? That's your period. So remember, I'm going to just do C down here. So 2 pi over b is your period, and b is pi over 10. So that is keep, change, flip. Those cancel out, so it'll be 20. So it's 20 seconds. Okay, and how high will you be at 15 seconds after the tide begins? So that means we got to plug 15 into the problem. So we have to figure out f of 15. So it's negative 60 cosine pi over 10 times 15. So put those all in parentheses when you do this, plus 66. And when I plugged it in, f of 15, I got 66. So that's going to be high. You know, I'm going to be at the max. Oh, no, not the max. I'll be at the midline is where I am. So that's good. And are you going up or down at that time? Well, I'm at the midline. I don't know. Okay, so I kind of have to look at the graph, figure out how long the period is. Well, I can do this. My period here is 20, correct? So that means it takes 20 to make one complete cycle. So at 0, I'm at my lowest. It is negative cosine, so I'm at I'm at 6 feet. So that's lowest, lowest. Highest here is going to be at 10 seconds. So just basic sketch of the graph, at 15 seconds I'm going to be on this side of my max, so I'm going to be going down. Okay, you can always just plug this into your calculator, but you still have to kind of know what the period is, and right in between is where the max is. And you know it starts at the min, so you know it's going up till it gets to the min. Till it gets to the top of the ride at 10 seconds, and then down again. So you have to be able to at least sketch a graph a little bit. All right, this is basically the exact same thing as the last page. So I'm just going to, I'll write the answer out and see how it goes. Each section at a time and just explain it. Okay, so I'm just going to do this piece by piece. So when I do this problem, I want to derive a sinusoidal model. In order to do that, I do like to have the sketch already done. It does help with the pieces. But you should be able to tell it is high tide at 32 feet and low tide at 2, so that should be pretty straightforward. It goes from low tide to high tide. High tide, to low tide in 6 hours. So at 9 a.m. it's at 32. At 3 p.m. it's at 2 feet, and that's your low tide. So that takes 6 hours. So another 6 hours would give me back to my high tide, and that's 12 hours total. So that's my period. So from high to high is for cosine. So it starts at the max, so you know that's got to be cosine. And positive cosine. So then I have my max, my min, and my period, and I just do my D, max plus min, A minus min divided by 2, and B, 2 pi over B is equal to the period, which is 12 hours. So cross multiply and I get pi over 6. So the sinusoidal model is this one. This is an equation. And then after I've drawn the, after I've graphed it, you can be as specific as you want, but just make sure you label your height over here, that it's in feet, time since 9 a.m. because that's where this slash is, and then, a couple of places where those are. You don't have to do the midline, that's unnecessary, but you do need it in the equation. Okay? Okay, to do this one, you just simply have to plug 11 into the equation. Now the reason that it's 11 is because we're looking for at 8 o'clock. 8 o'clock is right here. So how many hours is that since 9 a.m.? So you don't put 8 in, you put how many hours since your beginning of the graph. So that's 11 hours. So I plug that into this equation here, and when I do, I get 29.999. So at 8 hours, it's right about here. It's pretty close to being at high tide, and it's going up. So the tide is going in, is what that says. It's getting closer to high tide. And at what time of day will it be high tide again? Well, we figured that out way back in the beginning. It's going to be at 9 p.m. And then no date change, so that was 5/7. Okay, this one you need to use the equation, so it's the same as that other one, just different numbers. So the highest you will reach, that's your max. So it's the max is positive the amplitude plus 25, so that's 45. And negative the amplitude will be the lowest you would reach. So this would be feet. How long will it take you to go around the Ferris wheel once? Well, C is your period. So 2 pi over B, and B is pi over 5. So it's 2 pi over 1 times, keep change flip, so it would be 10 seconds. That is a very fast Ferris wheel. How high will you be at 15 seconds after the ride begins? So you have to plug 15 into the equation. So, it's y equals negative 20 cosine pi over 5 at 15 plus 25. So plug that in. So y equals 45. You're at the max, so it's 45 feet. That's nice. Okay, and are you going up or down? Well, if I'm at the max here, I'm neither going up nor down. I'm at the max. Neither. Okay, this one here is going to be a mess because I think this might be a typo here because my midline is at y equals 2. This is my midline here, and it goes, and the amplitude is 3. So going through the point 0.06, I believe it should be 0.5. So I apologize if that caused you a lot of strife, but it's going to work out, so assume it's my fault if that's the problem. So the max is 5, the min is -1. So this tells me if I'm graphing here, this tells me that the midline is 2, the amplitude is 3, the period they said is 12, so the interval is 3. So this is 12 right there. So this is 1, 2, 6, 3, 9. So it's going to go through 0.5 again. Really sorry about that. So, and then at the midline, the min, the midline, the max. So I did figure out the range. It was 5 and -1. Just did it right on the graph. All right, sorry, if I want to write the equation, the only other thing I need is b. So 2 pi over b is equal to your period. You cross multiply and solve. We've done this so many times. It is pi over 6. So the equation is y equals a. It's positive because it starts at the max. Cosine b x plus d. Hope the next one I didn't screw up. All right, this one here, same type of equation. We just need to hope that I didn't screw this up. Okay, one cycle of a function. So if I'm graphing, I'm going to graph and write the equation. So only thing different is I do need b to write the equation. So d is y equals -2. The amplitude is 3. The period is 16. So if the period is 16, then the interval is 4. The max, I like to do my max on the graph if I have one, because it just makes it easier. So my midline is at -2. The amplitude goes up 2. And, well, that's the max would be, I'm sorry, up 3. So that would be +1. And the min is down 3, -5. Okay, so this is sine. They're telling me this is sine, so it does start at the midline. But we want it to go through the point 4, -5. So let's figure out if my interval is 4. I'm going to make this 4, 8, 12, 16. So this is my 4, so 4 -5 would be right here, so that means the sign is going down. The next one would go up, then it would go to the max, then would go to the midline again. So since this is sine and it goes down to start, my amplitude is negative. So the equation is, well, the b is pi over 8. Just, 2 pi over b. Sorry, 2 pi over b, not 16, is equal to the period. I just feel like we've done this so many times. I feel like I'm repeating myself. You cross multiply and solve and you get pi over 8. So it's a sine bx plus d. These are just review problems. I'll just go through them real quick. You just want to solve each one of these, rewrite them. This one, particular one, if it's a fractional exponent, it's a rational, remember there's a 2 here, we want to write it as a fraction. It's 3 over 2. And then this is x. I should make this bigger. I'll do it next time. And then since we're dividing, we subtract our exponents. So when I subtract my exponents, I get x to the 2 over 2, which is just 1. So y equals 1. The bases are the same, they drop out, so y is 1. So 28, I'm just going to make this a little bigger. Whatever. Oh my god, I can't do this. So I change this to a fractional exponent. Remember, this is the bottom, this is the top. X 2 over 3 over x to the 5 over 3. So then we're dividing, make that an equal sign. So when you're dividing, you subtract your exponents. So when I subtract my exponents, I get x to the 2 minus 5 is -3 over 3. So this is x to the -1. Bases drop out, and y is -1. 2 minus 5 is 3. Yeah, okay. This one here, same thing, just the fractions that we have to change is on the bottom. So with this one, we get x to the 7 over 5 over x to the, remember this is top, bottom. Subtract those. 7 minus 4 is 3, so it's x to the 3 over 5 equals x to the y. The y's drop out, and I'm left with 3 over 5 is equal to y. Over here, same thing. X to the 6 over 7 divided by x to the 8 over 7 is equal to x to the y. We subtract 6 minus 8. The denominators are the same, so when you subtract, you can just subtract the top. So it's negative 2 over 7 is equal to x to the y. The x's drop out, and we're left with negative 2 over 7 is equal to y. With these, you're just expanding logs. When you expand logs, when you multiply, you add, all the rules. So log of z to the third times x to the 1/2, make those fractions. So then this would be log of z to the third plus log of x to the 1/2. The exponents go out in front. So it's 3 log z plus 1/2 log x. Just a bunch of the same things. Ln of z squared plus the ln of x to the 1/3. The 2 goes out in front. 2 ln of z plus 1/3 ln of x. These are all multiplying, apparently. Ln of x to the 1/2. So we're just changing these. I'm just doing the ln part. Because you're multiplying, they get added. The logs get added. So there we go. And then these 1/2s go out in front. And the 1/3 goes out in front. And finally, last one, log of x to the 1/3 plus log of x to the y, to the 1/5. These 1/3 comes out in front, and the 1/5 comes out in front. And that is all.